On the leap day, the 29th of February 2016, a bright light and a strange noise filled the skies over northern Scotland. It was later identified as a meteor breaking up as it entered the Earth's atmosphere. But not all extraterrestrial bodies break up before they hit the ground.
Brand new research in this part of Scotland suggests that something extraordinary and unbelievably powerful happened here to shape the landscape. Could northwestern Scotland have suffered an asteroid strike almost as catastrophic as the impact that may have wiped out the dinosaurs?
Scattered all along this coast is evidence of a major event of extraterrestrial origin. I'm headed out into this spectacular landscape to find out what happened.
As a paleontologist, I'm fascinated by the sometimes violent geological events that have shaped our planet.
Oh my goodness, they're everywhere. Yeah, they're everywhere.
Loads and loads of them.
Oh, look.
My asteroid hunt will take me along the finest beaches, up the most epic mountains, and craggiest, most remote sections of coastline.
It speaks to you, it tells you about where you are.
In search of evidence for an ancient asteroid crater that might not only be the first to be found on mainland Britain.
It's smash, 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 raining down over everywhere.
Everywhere,
In the
that's
vicinity.
it.
It could be amongst the biggest on the face of the Earth.
This is utter catastrophe in a matter of minutes.
This coastline is a lovely place for a walk. You've got sea, in the distance views of epic-looking mountains. But of course, it's more than just beautiful. And despite the fact that people have come here in their thousands to study the rocks in these parts, there are still secrets to be uncovered. And a new discovery along this coast, in these very, very cliffs, is pointing towards something remarkable. Something explosive.
My geological mystery trail begins a mere 2 hours' drive northwest of Britain's most northern city, Inverness, at the Northwest Highlands Geopark. Within the park is a magical landscape of 3 billion-year-old rocks, majestic mountains, lochs, castles and beautiful white sand beaches, complete with turquoise water. My extraterrestrial investigation takes me from Clactol Beach to NR Bay. Inland, up the mountain of Stack Polly, along Loch Assynt, and to the caves of Inch the Damph. Finally, further inland, I'll hear the latest evidence in the search for the asteroid's long-lost crater. Before I start my walk, I want to get a feel for how the ancient landscape would have looked before and after that asteroid landed. The best place to do that is on the astonishing white sands of Clactol Beach.
And it's not just the beauty here that is stunning. The rocks hereabouts, well, the ages of them are absolutely mind-blowing.
Joining me on the beach is Dr. Laura Hamlet.
This is possibly one of the most spectacular beaches I think I've ever been to. Yeah, it has that effect.
As a geoarchaeologist for the Geopark, she has a handle on the awe-inspiring rocks that make up her own backyard.
Can you talk me through the stunning landscape that I've got around me here?
Okay, so around the beach here, you've got the 2 different rock types. You can see up on the hill there, you've got the Lewisian gneiss, 3 billion years old. It's one of the oldest rocks in Western Europe, and it's the oldest rock in the British Isles, that's for sure. And then the outcrops around the beach, these are the Torridonian sandstone. Probably about 1 billion years old, so a little bit younger.
The phenomenally old Lewisian gneiss underpins the landscape here. But sitting on top of it is this very different purplish rock, Torridonian sandstone.
You've got the Lewisian gneiss. I mean, how did that form?
It probably started life out as maybe volcanic, deep underground for many, many years. Almost liquid at points, it was so hot. And then eventually it popped up to the crust surface again and became the landscape.
And it's into that landscape that we get the Torridonian sandstones
That's
forming.
right.
Now, how did that come to be laid down?
So the material that makes it up was basically weathered and eroded from a vast mountain chain, which was off to what's now the west. And at Clactol just here, we've got some very fine sediments, which shows us this was a lake bed. And it's been wetting and drying, which causes these desiccation cracks. Locally, we actually refer to these ones as Frankenstein stitches. It's a much better description.
That is a much better description. That's brilliant. It really does look like a stitch. So we've got, this incredible geology. Has it influenced the life of people locally?
Absolutely. The sand here is actually made up of fragments of Torridonian, fragments of Lewisian, but there's also quite a bit of shell in it as well. So the shell creates an alkaline soil, essentially. So you get around areas like this what's called maca, which is a very fertile soil, so excellent for farming.
You can see the little crofters' farms hereabouts, and I mean, that's just lovely. That's all partly due to the geology.
Yeah, the geology creates this lovely fertile soil.
This beautiful landscape is the ultimate in low population density. Vast open spaces interspersed with little crofters' cottages and fishing villages. But to get on the trail of the mysterious asteroid, I have to leave the present day and head way back into the past, to a time long, long before humans came onto the scene. I'm heading to Enard Bay. It's here that I'm meeting up with an old friend.
Spectacular
It is.
coastline.
It's pretty idyllic, isn't it?
Dr. Mike Sims is the curator of paleontology at the Ulster Museum.
But there's something a bit further along which is really very unusual. And that's the thing that actually tempted me here.
For the past 5 years, he has been investigating clues on this coast, and he's recently discovered something completely new. Mike's been analysing this rocky outcrop called the Stack Fadder Member.
It looks just like more sandstone, doesn't it? And in fact, for decades, it was thought to be sandstone, until about 50 years ago when people actually realised that this is actually something a little bit different.
1.2 billion years old and 12 metres thick in places, it contains clues that have long proved puzzling to geologists.
There's a lot of sand in there, but in amongst it, there's these little green blobs.
Yeah.
There's one there. There's a little piece there. And those were pieces of molten rock. That's not like a river sandstone at all. That's something quite different. So what sort of environment do you find molten rocks in generally?
The obvious one being, say, lava, for example.
And this
Molten
isn't a
rock.
lava flow because it's got all that sand mixed in it. It was thought to be a volcanic mud flow, a lahar, but it would still have been pretty hot. You're talking 200-300 degrees centigrade. And it stretches for about 50 kilometres along the coast to north and south.
A lahar, a debris-laden slurry of ash, mud and water, is a truly devastating natural disaster. The idea that this was all caused by a volcano continued until around 2008, when various researchers started suggesting that perhaps something even more dramatic was responsible.
So what are we looking for?
We're looking for little pea-like things sticking out of
oh,
the...
goodness, they're everywhere.
Yes,
they're
there are
everywhere.
loads and loads of them. If we...
Oh, look. Yeah. Wow.
These are actually what's called accretionary lapilli.
Right.
Bit of a mouthful.
It is a bit of a mouthful, yes.
And the reason they're called accretionary is because they've actually got layers. When you cut one through, they're almost like an onion.
These little balls can be formed in the roiling dust clouds that accompany volcanic eruptions.
They're produced in very hot clouds of dust. Dust particles stick to an original little rock fragment or crystal that's being carried up by the heat, and perhaps it'll sink down a bit, and then more turbulence will lift it back up, and another layer will go on it, and it'll get bigger and bigger and bigger. But of course, eventually, it's going to get too heavy, and then they sort of will rain down out of the sky. So accretionary lapilli are very characteristic of some types of volcanic eruptions. It all fits in with the notion that this was an absolutely massive volcanic eruption.
So what's the mystery then?
There's no evidence of any other volcanic activity at all. And that puzzled the geologists for decades.
With the absence of volcanic activity in this place at that time, there had to be a different explanation. Mike is part of a growing group of scientists who are putting forward a totally different theory.
Back in 2008, a team of geologists led from Oxford University, they looked in detail at various aspects of this deposit, and they said, no, this isn't a volcanic deposit. This has been caused by a meteorite impact. And that is just...
Yeah.
You think, oh my goodness. Once you know that, suddenly things become a lot clearer. You can explain why it's so thick and why it is so extensive. This was a really, really big impact.
The evidence on these shores points to a massive asteroid impact somewhere here 1.2 billion years ago. Over a pint in a pub just to the south of NR Bay, Mike presents two more tiny but conclusive pieces of evidence.
To prove that it really is a meteorite, extraordinary claims require extraordinary evidence. And there are two key bits of evidence that you actually find in the Stackfadder impact deposit here. One of them is an element called iridium. And I've actually got a little nugget with me.
This nugget is from Mike's museum.
It's the rarest non-radioactive element on Earth.
It's really heavy.
It's denser than gold.
Wow. So rare on Earth, but found in meteorites.
It's a little more common in meteorites. But the other thing that cannot be argued against is shocked mineral grains. When a meteorite comes in, it's going very, very, very fast. And so when it actually hits the ground, it comes to a rather abrupt halt. And that creates incredible pressures. And a team of geologists from Australia found a mineral called zircon in the Stackfadder member here. It's a very small crystal,
Tiny,
you see.
50
Tiny,
microns, that's like thinner than my hair.
Yes, but you can see these lines going through. Those are an extremely rare, high-pressure mineral called reedite. And reedite is only formed by extreme pressures, because the meteorite's coming in at perhaps 18 kilometres a second. So these are incredible pressures that are never generated really except by meteorite, a big meteorite impact coming in at that speed. And it all happens in an instant. So that's...
It's conclusive.
Yeah, definitely a meteorite.
It's certain that an asteroid hit the Earth somewhere near here 1.2 billion years ago. But given that no asteroid crater has ever been discovered in the British Isles, if it did land, where is it? And how big was it? I'm in the West Highland Geopark on the trail of a long-lost asteroid that hit somewhere around here 1.2 billion years ago.
Those kind of numbers are so far beyond the human scale, they're almost unimaginable. To get a sense of just how much time has passed between now and then, I've come here to the mountain of Stack Polly.
I've left NR Bay and I'm now on the foothills of the beautiful 612-metre-high mountain of Stack Polly. In this part of Scotland, good non-slip walking shoes and some wet weather gear is essential. The weather can go from blistering hot sun to torrential downpour at a moment's notice.
It is magic up here. Absolutely magic.
Love it. Never tire of coming up at all.
I want to get a handle on the landscape, and who better to ask than someone who climbs these mountains every single day? Ken Keith.
Oh, look at that.
Pretty good, isn't it? What's the effort?
It'd be great if you could just talk me through what I'm looking at right now.
Sure. All the way down just to below us here on Stack Polly. Very flat, very hard rock, Lewisian gneiss, 3,000 million years old. It's got lochans in it. Knockin' is something that you might have heard.
The knockins of the hummocks.
Yes.
Yeah, and the lockins of the little lakes.
Absolutely.
Lovely. Knockins and lockins. So you're looking this way.
All of a sudden,
Beautiful, beautiful hills.
Torridonian sandstone comes in and a mere 1,000 million years ago. This was deposited, which is fantastic to see. Glaciation's had its impact, obviously, as well.
These mountains, sitting on top of the 3 billion year old Lewisian gneiss, are made of the same reddish rock I saw on the beach at Clactol, Torridonian sandstone. They are the result of layer upon layer of accumulating lake and riverbeds, thousands of metres deep, eroding into the shapes we see today. It's hard to imagine a more powerful visual demonstration of how awe-inspiring geological processes can be.
Dark hill in the distance on the left is Cognac. Slightly nearer, with the sunshine on it, Sylvan, with that lovely banding on it. And then slightly further to the right in the distance, Canisp, followed to our nearest and on the right, Coolvore. And as a climber, it can be a little bit of a heaven. This sort of stuff is really, really grippy.
Yeah, because it's sandstone, right? So
Absolutely.
it's quite coarse.
It is very coarse. But it also has these little gems that help you on your way. This tiny little pebble here, you feel as if you could just flick it off with your finger. But I can assure you, with a little bit of experience and effort, you could just pop your toe on that, take your weight, and then hopefully move on to something a little bit bigger.
It's been there for 1 billion years.
It is.
Standing up here and getting the lie of the land, it's clear that an awful lot has changed in 1.2 billion years.
When you look at a landscape like this, it's not just the fact that the rocks are so incredibly ancient. It's the story that they tell of landscapes evolving over eons and eons and eons. Mountains have been built, they've been worn down, seas have come in, turned into mountains that have been built and then worn down again. I mean, these are serious, serious periods of time and serious, serious geological processes. When you think of the landscape like that, it seems impossible there could be any remnants of a 1.2 billion year old meteorite crater. But that's not going to stop me looking for it.
The geological evidence, alongside iridium and shocked quartz, leaves us in no doubt that an asteroid really did land here. But there are still major questions to answer. The first is how big this impact might have been. Was this a smaller asteroid, like the one seen in the sky recently over Russia? Or was it more substantial, like the 50-metre-across iron-nickel meteorite that made this 1-kilometre-wide crater in Arizona? Or really big, like the 10-kilometre-wide space rock thought to have killed off the dinosaurs, leaving a crater over 100 kilometres in diameter? Whatever size it was, recent events have made it clear that meteors are no strangers to Scottish skies.
Meteorites falling out of the sky might seem improbable, the stuff of myth and legend, but one flew over the skies of Scotland just in February this year. They're not as rare as you might think.
I'm taking a brief detour from the search for the crater to find out about the space invaders of today at JSL Observatory near Inverness.
Wait to do another driving lesson. I was just coming back from
By a stroke of luck, driving instructor Bill Addison captured a Scottish meteor on film.
As I was driving along the road, and then there was a huge, big blue flash in the sky, and you could see this thing falling out of the sky. Ooh. Yeah, it was quite weird to see. Like,
What did you do?
Well, I just kept going. But, you know, I wanted to see what it was. So when I stopped to pick up my student, I had a look at I went out my dash cam and I managed to have a wee look, and it was there.
Can I see the photo? Come on,
Absolutely.
come on.
But down here, it was a really dark night, actually. And there he goes.
Oh my, wow.
It was too quick to go down, like if it had been a plane, so the only thing it could have really been was probably a meteor or something coming down, like, you know.
I'm surprised that you and the driver in front didn't swerve. It's incredible.
The meteor, probably around the size of a football, released so much energy as it burnt up in the atmosphere it lit the night sky. At this observatory, amateur astronomers watch the skies for much bigger asteroids than Bill's.
So you're monitoring these asteroids. What do you actually do?
We can use a telescope to watch the asteroid pass in front of a star. I can show you the video. We were asked to monitor a particular asteroid called 196 Philomela. And this is the star that we were watching called HIP 36221.
Star in the middle.
That's the star. And in a moment, it will seem to disappear. It doesn't disappear completely. You can just see a faint light as the asteroid passes in front of the star. And it'll come back on. There we are.
Look at that.
And by working out how long it takes for the asteroid to pass in front of the star, it means that we've got a good idea of how big it is.
So how big was it?
It's around 145 kilometres in diameter.
That's massive.
Certainly is, and we don't want one of those hitting us.
No, definitely not. Good job of watching them.
Thankfully, that monstrous piece of rock isn't heading our way. I'm back on the coast in search of the lost crater of an asteroid that did hit us, with Dr. Mike Sims.
Where are we heading off to?
Well, we're heading beyond that kind of dark headland to a place called Second Coast.
That's a long way.
It is
a long way.
It is a long way.
He's going to take me to a place on this coast that he thinks will help give an impression of the scale of the impact. And intriguingly, we're going to need a boat to get there. I might be cheating here by taking a boat to Second Coast, but walking this leg of my journey would probably take a minimum of 2 days.
This is pretty spectacular.
It is. Glorious.
As we head out, we pass the beautiful Summer Isles.
That one's the big one, isn't it? Tamra Moor.
It is, yes. I think recently for sale. If you, deep pockets. I love it.
Oh my God, amazing.
Yeah.
Well, what a spectacular place to live.
Arriving at Second Coast, the 1.2 billion year old Stackfadder member is clear to see. But there is something eerily different about it.
Wow,
Here we are at Second Coast.
we have come a really long way.
It's about 30 kilometres in total is Enard Bay, where we've come from.
Mike has brought me to a 1.2 billion year old riverbed of fine red silt that has been exposed by weathering.
So it's just a river just sort of slowly flowing along, and then all of a sudden something catastrophic happened that changed everything in this region for quite a long time. When we look over here, what do you see?
Oh, yeah, I can see some like really kind of angular blocks.
Yeah, they're boulders sitting in this riverbed, and they really shouldn't be there.
I can see many more of these big, pale chunks of rock. But could these blocks have been brought here by something like a flood?
Aha!
So there you've got this enormous chunk of Lewisian gneiss, which when you do the sums it must weigh tens of kilograms, 100 kilograms perhaps. And you look at the size of the sand grains that's embedded in with.
Yeah, tiny. There's no way a river of this strength could have rolled or moved this boulder itself. It also, to me, doesn't look like it's been rolled.
No! So something quite different for this block here and the other blocks we see.
So basically, they either come from somewhere, it's not a flood. Something has embedded this so it can cut straight in a vertical way.
Yeah.
Which implies it's come from up there.
It can only have come from the sky, yes. It's been launched at speeds of 4 or 5 kilometres a second, shot probably tens of kilometres and then embedded itself in.
There's so many of them. You're just picturing that instant that, this kind of calm, gentle river. And like boom, boom, boom. Suddenly.
Horrific, absolutely horrific. Terrifying for anything that was living here at the time.
But of course, nothing was.
No, so no animals were harmed.
These chunks of rock would have been flung out of the crater created by the meteor impact. Alongside the molten rock and lapilli I saw earlier in my journey, they make up what is called the impact ejecta.
Clearly, there was a meteorite, and given that its ejecta stretches all the way to the north, far beyond Clactol Bay, and a good way to the south of here at Second Coast, it must have been a really big one.
We might not know where the crater is yet, but these blocks are made from the local bedrock, Lewisian gneiss, so the crater they came from must be out there somewhere. After a swift journey back across the bay, I get my walking boots on for a trip inland. To find out more about the rock that the meteor smashed into, I'm heading inland to Loch country. Here, the 3 billion year old Lewisian gneiss bedrock is so compressed and dense water can't drain through it, creating a water world of lochs and lochans.
This is quite a nice spot. If you just get yourself established down here, you can just stand yourself down.
Round
there.
about here?
Fly fisherman Stuart Yates and his faithful companion Geo the English Shepherd have offered to show me their secret trout fishing spots.
Okay. All you need to get the hang of is just that little flick action. Okay. There you go. That's fine. That's fine.
In this particular area here,
Yeah.
what kind of fish will we be likely to find?
This is all brown trout. In this small river, you get brown trout. This land is just studded with many, many lochans. There's almost as much water as there is land here,
Wow.
which is great news for me.
What is it about the rocks of this area that make the waters just so great for fishing?
The waters here are basically absolutely pristine. Up above here, you've got a large glacial moraine made up of all sorts of different gravels and stones and different types of minerals. So that'll add nutrients into the water as well. And that will feed the small bugs, which then will feed the small fish. And then the small fish will hopefully grow into big fish or directly feed the bigger fish.
I mean, what you're saying is, it's one of those little beautiful moments where geology becomes more than just science. It's setting up the basis for a successful environment for trout to grow in.
Yeah, and many other things.
I mean, the things that anglers can fish in, that crofters can use as fish farms effectively.
Yeah. Geology is, people look at, just the rocks, they're just there. But also, it speaks to you, it tells you about where you are. You're standing on it.
The stuff that our world is made of,
Yeah.
affecting our lives in ways we didn't even know it was doing.
Is that just flick it out? How on earth did you manage to do this?
I don't know.
Well, my fly fishing skills still have a way to go, so I'm going to leave the brown trout untroubled and continue inland. I'm heading for a mythical Scottish landscape of water, mountains, castles, and polar bears.
The most complete bear skeleton of that age ever found in Scotland.
And I hope to get a fix on where the asteroid landed.
It's sort of stretching almost as far as the eye can see.
I'm on the trail of an asteroid that left tantalising clues scattered across one of the most beautiful landscapes on Earth, the coast of northwestern Scotland. I've walked inland to Loch Assynt to find out more about this landscape.
Loch Assynt marks one of those many geological junctions to be found in Assynt. I've left behind me the ancient 3 billion year old Lewisian gneiss, topped by those towering red sandstone mountains that were laid down themselves 1 billion years ago. And now, the rocks I'm walking on, at a mere 500 million years old, are Assynt's youngest. And all 3 of those rocks were used to build this, Ardvreck Castle.
Getting up close, I can see limestone boulders alongside the purplish 1 billion year old Torridonian sandstone and grey blocks of 3 billion year old Lewisian gneiss.
Legend has it that the devil had a hand in building Ardvreck Castle when Clan MacLeod enlisted his help. In exchange, they offered him the hand in marriage of the daughter of the chieftain. Quite understandably, she objected and, to get out of such an awful situation, flung herself into the lake, where she became a mermaid, her tears filling up the loch. In return, the devil responded, and he rained down chaos from the heavens, rocks falling down to destroy Clan MacLeod's local empire. Now, of course, that makes you think about meteorites, but this story dates from the 16th century, which is an awful long time after that 1.2 billion year old meteorite that I'm here to look into.
Ardvreck Castle is a classic chieftain's lair with strong walls and views for miles around. But I especially like the use of a loch for an extra ring of defence. Geology as fortifications.
In most parts of the world, a set of 500 million year old rocks would be considered pretty ancient, but here in Assynt, they're the youngest they've got. Now, these Cambrian limestones are really different to the Lewisian gneiss back on the coast. That ancient, impenetrable to water rock creates a waterlogged, peaty landscape full of those little lochans amongst the nockens. But on the limestone, the water can penetrate, making the land great for farming and creating these lush, green, water-filled valleys. But that water can also penetrate down into the rocks themselves, and it's under the ground that something really magical happens.
While I'm here, the paleontologist in me can't resist investigating the bone caves of Inchnadanf, just northeast of Loch Assynt. Each one named after a local species.
Badger hole, reindeer hole and foxhole.
Yeah.
Right.
And there's 8 of them altogether.
I'm here with Alan Jeffreys, one of the founders of the group that mapped these caves.
So, these are the infamous bone caves of Inchnadanf.
That's right, yes. This is a particularly big cave system. It contains about 3 kilometres of passages and is currently the longest and the deepest cave in Scotland. There'll be cave wandering all over the place in 3 dimensions, all one on top of the other, running underneath each other. These caves do literally communicate, but they're full up with muck, and you can't, without extensive excavation, I mean extensive excavation, you're not going to get in.
Since the 1970s, Alan and his team have been mapping and clearing parts of the cave system. Their explorations have revealed anything from crawl spaces to flooded chambers. Huge open rooms deep inside these hills. But the caves also contain what I would consider to be buried treasure. In 1927, paleontologists from Edinburgh University found something that has never been seen before or since in the British Isles.
So they clearly excavated out the majority of this cavity, which is a lot of sediment. Did they find anything interesting?
Oh, absolutely. They found evidence of tiny things like voles and shrews, right up to reindeer, and indeed fragments of a polar bear.
Polar bear?
A polar bear, which obviously gives you some indication of what the landscape was like between the glaciations anyway.
Do we know how old the polar bear is?
Well, I believe the polar bear has been dated provisionally to about 18,000 years before present.
That polar bear is the only one ever to be found in the British Isles. But Alan and his caving group have been keeping up the tradition of discovering the bones of long-lost beasts.
There were 5 or 6 of us present. It was a brand new cave. Nobody had ever been there at all, ever. So we're the first people there, and what should we find but bones lying on the floor? We realised it was a bear. We could tell that from the jaw, and they were identified as a brown bear. And we extracted as many bones as we could collect. And it turns out to be the most complete brown bear skeleton of that age ever found in Scotland, and dated to about 28,000 years before present.
The cavers' finds have given us a rare and precious glimpse into life in Scotland in the Ice Age.
These are the sorts of things that were found in the Inchnadanf bone caves. Not the real fossils, unfortunately, but a set of casts. Lynx, polar bear, fragments of brown bear, some teeth in the pelvis. Now, bones like these are only a tiny snippet of the entirety of that ecosystem that would have been around in Scotland during the last Ice Age and before then. But the thing is, most of it's been lost from this part of Britain because, of course, the glaciers that came down have scoured it all away, carving out the landscape. But it's thanks to caves like Inchnadanf Cave that could act as traps for those animal bones that we have at least a mere hint of what Ice Age Scotland would have been like.
With my trip to inspect the bone caves over, I'm back on the trail of the meteorite. I'm wondering whether Mike will ever be able to locate the crater. With mountains and caves forming over the years, what's clear is that a lot has changed in 1.2 billion years.
Everything I've seen so far clearly points to a meteorite hitting this area and profoundly affecting the landscape around it. But one very enigmatic question remains. Where did it land?
I'm walking just north of Clactol Beach to a place called the Bay of Stur. It's an astonishing coastal landscape of jagged cliffs jutting out into the aquamarine sea. Some of them are so big and angular they look like the upturned hulls of shipwrecks. Mike has been asteroid hunting in these parts and he thinks he's getting closer to finding the crater.
Well, I keep coming back to this, one question really, which is it must have left some evidence as to where it actually landed.
Yeah, and that's one of the amazing things about this particular spot. We can actually get an idea of where the impact was. And it's really, really obvious when you know what to look for.
Really?
Yeah.
Wait, I don't know what's... Yeah, show me. I don't know what to look for.
So you go up through layer upon layer of sandstone, and you've got more layers of sandstone up there.
Yeah.
But in between it, you've got some of this ejecta, the stuff that was flung out of the meteorite crater. And you can see there's a band of it here.
Yeah.
And as you follow it this way, you go like that, suddenly it gets much, much thicker.
I see, yeah. So it's thicker that end and then pinching out as you go up the slope this way.
It's a wedge.
Yeah. I want to come up and have a look at that.
Ooh,
You just come around. So we've got sandstone ejector.
Yeah. Then you can see some of the little green bits in it. So that's absolute proof that it is ejecta. If you follow it, if you keep following it, it thins down to just a couple of centimetres.
The sheer power of something forcing its way between these sandstone layers gives you a sense of how apocalyptic it must have been when the meteorite hit.
Yeah.
But does this wedge tell you anything more than the power?
The really exciting thing about that is that it gives an idea which direction it was coming from.
Because if it's wedging into the limestone this way, that gives you a hint that it was coming
from the thick end, as it were.
It was coming from over there.
Yeah.
In Mike's research trips, he's identified 4 of these wedges of asteroid ejecta. The wedges look very much like arrowheads, arrows that originated from a particular place inland.
Those wedges of meteorite ejecta are the last piece in this puzzle. You've got this sense of this giant meteorite impact and now really tangible evidence for where the meteorite might have landed, somewhere over there. And even more exciting, it seems to have hit in an area where we've got rocks remaining of the right age. Could it still be there?
With this new information in hand, Mike is ready to lead me to the location of our 1.2 billion year old crater.
We're right at the epicentre of this enormous crater, and you look at the size of it.
Finally, we will discover the true scale of this ancient catastrophe. I've been following the hunt for a previously unknown asteroid impact crater here in northwestern Scotland. After discovering evidence for where the asteroid landed, I'm about to join Dr. Mike Sims on a trip inland to finally find the crater and reveal just how big that asteroid was. But before we head off to look for the crater, I'm meeting up again with Dr. Laura Hamlet at a place called Knocken Crag. We may know roughly where the impact zone is, but Laura wants to show me something that suggests that the crater might have disappeared from sight.
Well, that is pretty clear. 2 very different types of rock. But what exactly are we looking at here?
At the bottom, we've got Durness limestone. This is around about 500 million years old. And then on the top, there's the Moyne schist, and that's around about 1 billion years old. So much older rock sitting on top of younger rock.
And that goes completely against one of the simplest, most basic concepts in geology, which is that the stuff that is lower down has to be older than the stuff above it because it got there first.
Absolutely, that's right. So in the 19th century, when geologists first came to this area to study this sequence, it didn't make sense to them. They had to puzzle it out. They studied this for the best part of 50 years before they actually were able to publish a memoir.
How did they start to explain it?
It must have moved somehow. And it was essentially caused by the collision of continents down at the border in between England and Scotland now. And this material was thrust up and over the limestone.
When did it happen?
Around about 430 to 410 million years ago.
This geological feature, now known as the Moyne Thrust, revealed a truly amazing phenomenon. As two plates collided over 400 million years ago, the older layer of rock thrust up over the younger one, effectively pulling a blanket of rock over where our asteroid could have landed.
If a meteorite landed somewhere in this area, it has not only got to have survived 1.2 billion years in that crater, it's got to be able to be found under all those layers of rock and potentially under this layer here, this potential shroud of the Moyne Thrust, which is a massive amount of geological Earth movements. I mean, can it be possible? I mean, how on earth could something that old have survived such extraordinary geological processes?
Despite the odds stacked against ever seeing the crater on the surface, the ingenious Dr. Mike Sims has been using every scientific trick in the book to track it down. He's found a new set of clues that suggest the crater is here, under this part of the Highlands. We're about 50 kilometres inland from the geopark, at a town called Lairg.
If you are somewhere near a big, massive crater, how on earth are you going to go about locating it? Because you won't see it on the surface.
No, there's a potential to find it because we can use geophysics. And very conveniently, the British Geological Survey have actually published a map of gravity. Gravitational changes. And gravity is all to do with the density of the rock. So really dense rock will have a bit more of a gravitational pull than a less dense rock.
I've got my eye in now. I can see the outline of the British Isles. So down here, this is the coast of Kent. Iconic white cliffs of Dover. We know they're made of chalk. Nice, low blue colours for low gravity. You know? And then we are up here.
Right up near the top.
And then you've got these like, dense rocks like the Lewisian gneiss. Red. So red equals high gravity.
Equals a lot of gravity. If you've got a great big hole dug into the Lewisian gneiss and then it's filled with sand and rubble, which is what happens with an impact crater, then you're going to get a gravity low there. You're going to get what's called a gravity anomaly. And up there is a gravity low, smack bang in the middle of a lot of dense rock.
And where is this?
It's named after the town of Lairg. Down
there, right?
Yeah,
so
it's got its own name, the Lairg Gravity Low. This is a simplified geological map of all the area that we've been travelling around in.
Alongside the gravity anomaly, those four groups of wedge-shaped dejecta that Mike found on the coast all originated from one spot. Where we are standing right now.
we are basically there.
Yeah, we're right at the epicentre of this enormous crater, and you look at the size of it. It's 45 kilometres across, so it's stretching almost as far as the eye can see. You know, you could almost imagine those hills there.
Being
the rim.
Yeah. What size meteorite would have caused a crater?
You're talking about 3 kilometres across. In terms of average speed, it's doing probably 18 kilometres a second.
Mike has calculated the impact would have released the same energy as a 1.5 million megaton nuclear warhead. That's 940 million Hiroshima bombs.
We've got these clouds, those clouds have been boiling away, and a massive fireball as it hurtled towards you and plunged into the ground.
Yeah, it's going to go 8 kilometres into the crust.
8 kilometres deep. That's as deep as Mount Everest, but into the earth.
But you can't have a crater like that lasting very long. And what happens in the next few minutes, the sides collapse in and the crater gets much bigger and it gets shallower as well. And all of this is happening really quickly. You're talking minutes. This is happening. It's not a long, gradual process. This is utter catastrophe in a matter of minutes.
This now buried crater would have been an incredible sight from the air, with a surface area over 1,500 times the 1 kilometre wide meteor crater of Arizona. Where does that place it in the Meteor Hall of Fame?
There's about 200 impact craters known on Earth. 40 kilometres places it in the top 15. There aren't many craters bigger than that on Earth. So it's extraordinary, you know, that underneath here is the epicentre of something, you know, perhaps one of the biggest impact craters on Earth.
The enigma of the lost meteorite has been solved. The ejector and shocked quartz confirmed that an asteroid landed here 1.2 billion years ago. The wedge shapes of the ejector led Mike to look inland for a crater, and the gravity low confirmed the location of the impact, telling us the crater was at least 40 kilometres in diameter, and the object that made it was around 3 kilometres wide. Back in the geopark, the coast is as beautiful as ever, but now I see it through different eyes. It's astonishing to think what happened here 1.2 billion years ago, and how this catastrophic event had remained hidden from science until researchers took a closer look at the incredible geology here.
Fresh eyes on an ancient landscape, and there you have it, evidence for one of the biggest meteorites ever to have hit the Earth. And it landed here in this beautiful corner of northwest Scotland.
A wild and wintry adventure here on 4 on Monday night. Chef Kieran Jethwa is in Mongolia tracking down extreme food at 8 o'clock. And in the early hours of Tuesday morning, what is likely to be an explosive and controversial showdown, Trump versus Clinton, the first of the presidential debates. Live coverage begins at 1:45 a.m. Scrapping it out around the letter trays next tonight. 8 out of 10 cats does countdown.